so state the factor on which each of the following characteristics of sound depends. So pitch depends on frequency, and loudness depends on amplitude. Okay. Now, next question says, a sound wave completes 3 cycles in 6 milliseconds. Calculate its frequency. First of all, we need to convert milliseconds to seconds. So it's a milli is equal to 10 to the negative 3. Therefore, 6 milliseconds is equal to 6 times 10 to the negative 3 seconds. So we've converted 6 milliseconds to seconds. Now, if you know what do you call it, definition for frequency, you'll be able to answer this question properly. So frequency, we don't need to write this, but I'm just writing it for you. So the frequency is the number of waves passing a point each second. Okay, so now we know that we could say if 3 cycles, according to the question, it says 3 cycles in 6 milliseconds. So 3 cycles pass in 6 times 10 to the negative 3 seconds. Then X cycles would pass in 1 second. Because it says frequency is the number of waves passing a point each second. So that's 1 second. Then, so hence, 3 times 1, so this goes up here, this comes on, divided by 6 times 10 to the negative 3 will be equal to x. Because remember, this is like saying 3 over x equal to 6 times 10 to the negative 3 over 1. You just cross multiply, so this goes up, this comes down, you want to get x back in the numerator, so it goes up. And so this will give us 500 cycles per second, which is really translated to 500 hertz. Okay? Or you could look at it in the period sense. So the definition of a period is the time in seconds for one wave to pass a point. So therefore, if 3 cycles or oscillations occur in 6 times 10 to the negative 3 seconds, then 1 cycle or oscillation would occur in x. And so if we write this out like this, 3 over 1 equal to 6 times 10 to the negative 3 over x. X, remember, this will go up, this will go down, that will go up. X will be equal to 6 times 10 to the negative 3 times 1 over 3. And that will give us 0.002 seconds. So that will be the time it takes for 1 cycle to pass a point. And since we have the period now, we know that if frequency is equal to 1 divided by the period, then we just say 1 divided by 0.002 seconds will give us 500 per second, 500 cycles per second, and that will translate to 500 hertz. Okay, so we got the answer twice. I hope that helped. Now we're moving on to question C. It says, figure 2 shows the side AB of a rectangular glass block and CD, which is the normal at the point 0. So we have side AB, right? And CD, we have CD, which is the normal, and 0. So this is a glass. It's the glass right here. And this is the air. Now it says, in figure 2, draw the path taken by a ray. So let me read again. In figure 2, draw the path taken by a ray of light which meets the glass, this glass to air boundary at the point O at an angle of incidence equal to the critical angle. So it's just saying, draw an incident ray that is equal to the critical angle. The critical angle causes the refracted ray to refract so much that it refracts along, it refracts along the boundary of AB. It doesn't leave, the refracted ray would not leave the glass, the surface of the glass. It would just, it's the biggest angle at which light is not refracted from the glass. It doesn't emerge from the glass then. So you wouldn't see a light coming out of the glass. It's the largest angle at which the light would not emerge from the glass, however, it would travel along the boundary. Alright, so that's the critical angle. So we'll say this is the incident angle, which is equal to the critical angle. Right? And so we have to label our stuff. So we're going to label our stuff. So here we have, and you put your arrows. So I put my arrow there. So this is our incident ray. Okay? And this is our angle of incidence, which is equal to the critical angle. It's also equal to the critical angle in this instance, because this is the largest angle at which the light does not emerge from the glass block. It just travels along the boundary. And then it says, label the incident ray, the critical angle, and refracted ray, the path taken by the ray. So the refracted ray, the ray that's supposed to emerge from the glass, will not. At this angle, it will travel along the boundary. That's the largest angle at which this is the instant. This is the angle at the instant at which the emergent ray, the refracted ray, which is supposed to emerge from the glass block, does not emerge. This is the angle. So this is our refracted ray. Then it says the glass block has a refractive index of 1.5. So determine the value of the critical angle of the glass. So you have a nifty calculation for that. Sine C, it's a sine of the critical angle, which is equal to 1 divided by the refractive index. So C represents critical angle, and N represents the refractive index. And we're solving for the critical angle. So to do that, we have to now do the inverse. So we're going to say if C is equal to the inverse of the reciprocal of the refractive index, we could now substitute or put our numbers in. We know we're looking for C. We have N. N is 1.5. So we're going to say C is equal to the inverse of sine 1 over 1.5. And that will give us, let's go. So to do the inverse is second function, inverse sine, and we do 1 divided by 1.5, as can be seen here. That's it. And you should get 41.8. Great. So we have 41.8 degrees. Good. All right. Now the last question. The ray of light now meets the glass to air boundary at the point O at an angle of incidence greater than the critical angle. So when you surpass the critical angle now, so that's the angle at which the no more light will be, the exact angle at which no more light is gonna emerge from the block. It's just gonna pass along here. The refracted ray would be perpendicular to the normal. That is what it is. Now if you surpass the angle, the critical angle, what's gonna simply happen is that what was happening as you open out this angle, as you move clockwise, as this moves clockwise, this angle here, like this, as it moves clockwise, this angle is moving clockwise as well. It's also coming down, so it's like an effect. It's like, just imagine here, and it's moving down, it's moving down, it's moving down as that opens out. So as it opens out now, it's gonna move away from the boundary, and it's gonna be reflected back into the block itself. Okay? It's gonna be reflected back into the block itself, and we call that total internal reflection. The question says the ray of light now meets the glass air boundary at the point O at an angle of incidence greater than the critical angle. And so on figure 3, they're asking us to draw a diagram to show the new path taken by the ray of light. And what we're gonna do again, we're gonna make sure we label. Even though they didn't ask for that, or I don't see it there, you're going to make sure you label. So we know I is equal to I, which is greater than the critical angle. Okay? So this is our refracted ray. This is our, I'm going to just labels on this side. Incident ray. And this here is our angle of incidence and angle of refraction. So angle of incidence all right. I hope this helps. I hope you see the light because this is all about light. So again, let's just run through it again. So state the factor on which each of the following characteristics of sound depends. Pitch depends on frequency. The louder the pitch, the higher the frequency. The loudness depends on amplitude. So the higher the amplitude, so this is the amplitude here. Amplitude, so the amplitude is the top of the crest to the place of rest, or the bottom of the trough to the place of rest. So it's between, is that space, the hump to the place of rest, right? Or equilibrium, to the point of equilibrium. So from the crest to the point of equilibrium, from the trough to the point of equilibrium. So this would give you a soft sound as opposed to something like this. This will give you a louder sound. Okay? So this will give you a soft sound, this will give you a louder sound. Pitch, if you have it like this will give you a soft, low sound, whereas this will give you this, like at the same amplitude, this will give you a soft, high sound. As the same thing as this, if you do this, if you go like this, the frequency is not so much, so this will give you a, like maybe a high, slow sound, and this will give you now, like if you have something like this, like you have more than here. This will give you a higher sound than this, and faster sound than this, right? High pitch, a higher pitch than this. Got it? This will give you a low pitch. Okay, so I hope that helped. And again, the frequency is the number of waves passing a point. The frequency is the number of waves passing a point each second. So I just use the definition to work this out. If you have 3 cycles passing in 16 centinegative seconds, then X cycles will pass in 1 second. And we just relate it like that. And we got the answer twice both ways. So you just need to know how to do your red diagrams to these questions. And once I said from the, how did I know to put it here? Because I said glass air. So it was going from glass to air. Right? And this usually happens when you pass light through a medium that is more dense than the other medium that is supposed to emerge into. Right? So they said glass to air. So I did the angle of incidence in the glass going towards the air. And like I said, when it's going from a more dense to a less than medium, you have greater refraction. And as you increase the angle of incidence, you're going to have a point at which you reach a critical angle where no light emerges at all from the glass block. And it is then perpendicular to the normal. Perpendicular meaning it forms a 90-degree angle. Alright. Now here you just work out the critical angle is 41.8, and this is glass, so we know the angle at which light would not emerge from a glass block would be 41.8 degrees. Okay. And 42 means that it's totally internally refracted. Once it passes 41.8 degrees, that means you're going to get something like this. No light at all. Moving along the boundary is just reflected within the block itself. So we call it total internal reflection. And that's a wrap. Bye.